in the multiple regression framework, then there are three ways we can measure the fit of our regression. One is the R squared, and the second is the standard error of the residuals, and the last one and the new one is the adjusted R squared. So in multiple regression, the R squared and the standard error of the residuals, they are the same as in simple regression with only one X variable. And so just to recap, the R squared is the explained sum of squares divided by the total sum of squares, right? and the standard error of the residuals is just the sample standard deviation of the residuals. So it's just the standard error of U. Okay, so why do we need, or what is the adjusted R squared? Well, the adjusted R squared is just denoted as this R squared bar, and it's equal to 1 minus this n minus 1, which is number of observations minus 1, divided by the number of observations minus the number of independent variables. This is the number of x's, right? Minus 1. Times the sum of squared residuals divided by the total sum of squares. So, and you know how to calculate the sum of squared residuals and the total sum of squares. And why do we need this R squared? Well, the problem with R squared is that whenever you add an X variable to your model, the R squared either stays the same or increases. And R squared might even increase even if the variable you are adding does not explain anything of the Y variable. So it's just a random variable creating noise in your model. So a model with more X variables will appear to have a better fit simply because the R squared does not go down, but goes up even with redundant variables. R squared was introduced to remedy this. R squared takes into account the better fit, but it penalizes that better fit by adjusting for the fact that you actually have one extra variable in your model. Okay, so that's why our adjusted R squared, it gives a better sense of goodness of fit, because if you add a variable to your model and R squared or adjusted R squared does not increase, then you know this variable does not add anything significant to the modeling of the Y variable. So some useful properties of adjusted R squared and R squared is that adjusted r squared is always lower than r squared because it takes into account the number of x variables, right? So you are penalized for having a too large model. And if you add a new regressor, then adjusted r squared can either be the same or increase, because the sum of squared residual falls, but this penalizing term increases, and because this penalizing term is above unity in value, then adjusted r squared might in fact be negative if the r squared is too low, and you don't have many observations compared to how many x variables you have in your model. And lastly, for large N and small k, which means that you have a lot of data and a small model, then this penalizing term is actually about equal to 1, which means that r squared and adjusted r squared would be quite similar. So, see you next time.